Hi guys, so in this video we will talk about the optimization performance of a delta lake. Okay, so we'll see here the optimize and vacuum command. We'll learn about that and we'll see practical what we'll do here. So in this video we'll well deeper into the inner working of a delta lake and put a light into the mechanics of drive and its functionality. Okay, so first. Uh, Let we'll see. Yeah, I have already written these commands here. So first we have create this table and we'll run this to create a table, okay? And then after we'll see this into our cluster in our database file system. You can see here we have created our table and it contains one JSON file in the delta log. Now we'll run the select operation here. So as you can see, no returns, no rows are here. Okay. Next, we will insert some values here into this table. So now what happened now? If we'll go inside the catalog explorer, okay, we'll see our file. So we have performed the insert operation, and now you can see here each insert will be treated as a separate operation. As a result, three different files will be created with each containing only one record. Okay, so you have seen here this record have a one part file, this record have a one part file. So there is a three records and three records in individual part files. So they are having a three part files. Now we'll see three JSON files have been created. Okay, so in the delta log, since the table state got changed thrice, okay, let's do some more insert operation here. So we'll run the three important insert operation again, and just like a previous one it will create a three part files again. So we'll refresh that. Okay, now we can see here six byte files are created, and then we can check into the delta log folder here having a six JSON file. Okay, so when we are performing any kind of operation, the data will be saved in part files and the metadata will come into the delta log folder as a new JSON file. Okay, now we'll again insert one file. You can understand here. Now we have a seven part files. I will refresh it again. Seven part files are here, and the delta log folder we have a seven JSON files. Okay, so we have inserted seven values, seven rows we have inserted. Now I'll check here. So we have a employee table. We have a seven values, seven rows. Okay. Now we'll delete one. Uh, we'll delete one file from here. Sorry, we just delete some. We just delete one record from here. So I will execute this. So we have a seven JSON file right now. Now I'll come to here. Now we have a eight JSON file, right? So how it will impact our Databricks file system? You'll see new JSON file is created in the delta log, whereas the number of data file remains the same, right? And seven files are here. Okay. So now question has been generated here. Like even after delete operation, the data file have remained same. Why? So the file not removed immediately. As you can see here, the file will not this the simple reason of time traveling, an important feature of the delta tables. Okay, so instead of removing this file, Databricks will simply mark that file inactive. Okay, and all this information will present in the latest JSON file, latest log file, that is 008.json file. Okay, so now let's do another operation. We just update our one of the record, so we'll update that. Okay, middle name is not there. I have to check. Last name is there. Okay, so we have to check the last name. Okay, then again we have updated employee table, and you can see here again we have a one file added in the delta log and in the part file also. Now we have eight part files, and how many log files are here? So we have a nine log files. Okay, so we have updated here one part file will be created and one log file also created in the delta log folder. And now again we will update this. Again one file will be created, and in the both side, in the part file also, in the JSON file, delta log file also. Okay. Now we'll optimize employees table. Okay. So here we come to the point why we have to use the optimize command. As you can see, we have created so many files, and in real time scenario, there may be millions of such small files, and Delta Engine will have to maintain all their metadata as well, right? So if these files are in millions when you are using in a when we are working in a production scenarios, okay, so on that time, what happened? This is very difficult to maintain than that time. So this is a process overhead, and it will affect the performance for sure. So it's not good idea to keep so many small files. Instead, we can combine these small files into a single file of a optimal size, right? So when we perform the command here, so if that file will be of less than 1 GB, so it will combine and become a one file. Okay, let's we do an operation. So I will explain you about the optimize command first. So this is the command. Optimize command is the command to compact a smaller sized file, and in the big data processing, having too many small files or too few very big files are not desired. So it's always good to have files with its optimal size. As for optimize, the default size is 1 GB. Okay, so if the data I have already told you, if these part files are of less than 1 GB, so it will be consolidated and it will combine to become one file. Okay, if it will be more than 1 GB, like 1.5 GB or 1.2 GB, so it become one and one two files, right? So let's will run this command. So if you read the log message, it says in that path, one file will be added here. Okay, one file will be added here, and six files are removed. Okay, six files are removed. New file is a now this one new file is a combination of this six file. Okay, and hence these six files are removed. When it says six files removed, it means that going forward the Delta engine would not refer this file and would only refer the latest combined file after optimize operation. But those files would remain present in the DBFS location. They are just removed for references. If you see the DBFS again, you see the DBFS again, you will see an extra additional 11th JSON file along with an extra, sorry, how many files are there? Three. 11 files are there and 11th JSON file has been created. Okay, so additional 11th file along with an extra JSON file in Delta folder has been created. Now I'll go to our cell. If you see the history of the table, you will find the following. Okay, you can see here 11 versions has been created right now, and we have 7 write operations has been done. One delete operation, two update operation, and one optimize operation has been done. So here we can see clearly all the operations that have been done on our delta table. And with every operation, a new snapshot version, right? A version of the table has been created, right? Let's move on to the second command that is helpful in optimizing our delta table. That is vacuum. So I will explain you delta table by default. Okay, keep the history files for time traveling and vacuum affect the time traveling. But over a period of time, if we do not clean up those files, it will continue to pile up. It will become as a garbage collector and it become a huge amount of data. Okay, it pile up huge amount of data, which is not good for maintenance and storage perspective because it will affect the maintenance. It claims a lot of storage area. Okay, having a small and large amount of file is not good, as we have already seen in the optimize command, and it also take a lot of cost. It will be expensive after all, so we must clean them periodically, and for that we can use the vacuum command, which help us to remove the unused file. So the files that are not a part of our latest version, we have to remove that. Okay, so first of all we'll run this command and we can see what is the result coming on. So here you can see it is asking about you'd like to vacuum files with such a low retention period. Like you can see, I mean, I want to explain you here. We can remove the invalidated files which are not a part of the present version of the table first, right? And second, files that have been that become invalid at least 7 days ago, right? Or 160 hours before. So, but before we remove this file, it always suggested to run a dry run. Okay, but first of all we'll look at the this command. First we have to set this file, this retention duration check enable. Okay, so why will make it true? Because if we want to run it for before run it for as soon as possible, okay, we can have to make it false first. Sorry, we have to make it false. Okay, now I'll be run this. So what is the value of that command? What is retaining 1 hours means it lists down those files that become inactive in the last 1 hour. Okay, and there is nothing in the last 1 hour. So we can also remove all the obsolete files, means unused file, by making retain zero words. This means that even the file just were that were just created and recently modified could be marked and deletion. Okay, that could be marked for a deletion if they are deemed unnecessary for query processing, right? So we can also run this. So it will list down those files that become inactive in recent manner. Zero words means before 1 hour, as you can see. Let's see what is the result of this query. Okay, so no files are there. If there is a file, so these files will be removed after a vacuum operations. Okay, now what we'll do, we'll describe the history first. Okay, so there is no availability of a file. Okay, I mean, uh, it does not list down those files that become inactive. Okay, in 1 hour. So that's why it was not showing us vacuum operations. Okay, otherwise it will show you here after optimize vacuum start and vacuum end. Okay, so if there is any kind of a retention, I mean there is having any inactive files, then it will vacuum up and it will show the operation here. Okay, so if you are trying the vacuum command, you can definitely see. And when we are using the vacuum, when we have to clean up the files, right? We have to clean up this unused file. Like there is a deletion file, there is a unused file, but you can remind that it will affect the time travel. Okay, you cannot use the version after all if you clean that, right? So I hope you got this. So thanks for that.